This video we are going to discuss about the monostable and astable sequential circuits. So on completion of this topic, students will be able to explain the combinational logic and also they can obtain the difference between the sequential and the combinational logic. So in monostable and astable sequential logic, here this entirely monostable sequence is determined by the signals, and this unstable signals are immediately affected by the input changes. So here the combinational logic is mainly, if you are giving x1 x2 as an input, the output will be z0 and z1. But here, since this is used for the storage purpose, here we are using the memories. And in the case of SR latches, so this is a circuit which is having the two cross coupled NOR gates, or we can say that is two cross coupled NAND gates. So the main thing of the one with the NOR gates and one with NAND gates is given in the diagram. So here you can see you are giving the value as 1 and 0 if you are giving as an OR value in SR latch, and next in the SR S also set and reset value we are giving 0 and 1 to the OR gate. We can produce in the set if it is Q bar means, or the reset value it be Q. So the input which we are giving as 1 0 means the output will be 1 0. Next 0 0 1 0 0 1 0 1 0 0 0 1 1 1 0 0. That is, if the set value s is equal to 1, then r value will be 0. If s value is 0 means then r value is 1. That is the condition. And here in this NAND gate, the condition is defined that when two inputs are equal at the same time, while comparing the NAND gate with the NOR gate, the inputs for the NAND gate will require the complement of those values which we are using in the NOR latch. So that we have explained in this NAND gate. In this NAND gate, if you are requiring the 0 signal to change its state, means it sometimes it changes from S to S dash or R to R dash. So this operation of this SR latch can be modified by providing additional control input. That is, we can change the state of latch to the completely, the state of the latch can be changed here. While seeing the timing diagram, here this control signals will be an enable signal from other two inputs. So when an indeterminate condition is occurring, means when all the three inputs are equal, this condition makes me too difficult to manage them both the things. So when giving the set value means the s is equal to 0, r value will be 0 is equal to 1, and if set is equal to 1, then r value is equal to 0. So these are the propagation delays while transmitting the pulses. So if we transmit the value, if you are setting the value as 0, the next pulses, if it is taking some delay, means it can takes the value to the constant mode, or it can remains in an idle state. And if you see the characteristics of the SR latch, here we consist of present state and the next state. So when you give the input as 0, s is equal to 0 or equal to 0, the present state will be 0 and the next state will be also 0. Since all the inputs are 0, there will be no change. And if we are giving a value of 0 1 and 1 0 1, the reset value will be 0 and set value will be 1. So based on this, we are drawing the K map here, and the latches with the two set inputs are occurring to be equal. When it becomes very difficult, when there is more conditions occurs in the circuit. And the next one is gated latch. So in the gated latch, one way to eliminate this undesirable condition is of this indeterminate state in the SR latch is to ensure the inputs that S and R are never equal to 1 at the same time. So this can be done in this gated latch. This is one of the advantage while compared to the previous latches. And if you see the SR gated SR latch characteristics, here we are using the enable states, excitation inputs, and present state and next state. So when you give the inputs to be set value and reset value, there will be no change. If it is giving 0 value, So enable inputs will be always 1, and if you give the inputs at 0 0, there will be no change. If it is 0 1, there will be a reset value of 0, and if it is 1 0, it will be having the set value. So this can be determined in the K map. And the delay latch, if we are giving the inputs, since we have this latches as a memory elements in the sequential circuits, and it is very difficult to raise, this output cannot be directly applied to the input, so that there will be some delay changes. So in that delay changes, it occurs to be idle. And in the delatch characteristics, there will be a hold, store 0 and store 1 mode. If you are giving 0 0 as an input or 0 1, there will be store 0, and if you are giving 1 0 and 1 1, there will be a storage of 1. And you can see the timing diagram. In this timing diagram, there is an enable stage, hold stage. So whenever there is a change in the delays, it occurs in the enable stage, and if there is no change, it occurs in the hold stage. And you can see the same thing in the timing constraints. And the next one is master slave. So master slave flip flop is nothing but this flip flop is mainly the combination of two JK flip flops that is connected together in the series configuration. So out of this, one acts as a master and one acts as a slave. The output from the master slave is connected to the two inputs of the slave input, and here you can see the output is connected to the feedback of the inputs of master flip flop. In addition to this, you can see two flip flops, that is the circuit which is acts as an inverter. It is connected to the clock pulse. So in that way, you can see the inverted clock pulse is given to the slave flip flops, and also whenever the CP value is equal to 0, this flip flop will be is equal to, then there will be a master flip flop, and if it is 1 means there is a slave flip flop. So mainly slave flip flop is 0 and master flip flop is 1. So you can see here the timing diagram. So in this timing diagram, when the clock pulse goes to 1, so you can see the slave is isolated, and this J and K inputs may affect the total system. So this slave flip flops will be isolated and it goes to 0 state. When it goes back to 0, this information from the master flip flop to the slave can be passed from one master to another slave, and the output can be obtained. First, this master flip flop is positive level triggered, and the slave flip flop is negative level triggered. So the master responds before the slave. So here if you see, if this J value is 0 and K is equal to 1, the high Q output of the master goes to the K input of the slave, and the clock forces the slave to reset the, and slave will copies the master. If J value is equal to 1 and K value is equal to 0 means there will be high output value, and if J equal to 1 and K equal to 1 means it doodles in the positive transition, and if J equal to 0 and K equal to 0 means it remains unchanged. So here, when this clock pulse is very high, the output of the master is also high, and it remains high till the clock is low, but because the state is entirely stored. So now the output of the master becomes low when the clock pulse becomes high, and it remains low until the clock becomes high again. Now it takes place for the clock cycle. When the clock pulse becomes high, the master becomes more operational but not the slave. So the output of this slave will remain slow and the clock remains high. So here, when this clock is low, the slave becomes operational and it remains very high until this clock again becomes low. So here you can see the toggling taking place while the process of output changing from one state to another state. And this is the pulse triggered JK flip flops. So normally in the flip flop you can see the storing 1 bit of information. This 1 bit memory cells we are using in terms of zeros or 1. Therefore this flip flop mainly is used in all the digital systems. And here, if this pulse trigger JK flip flop characteristics, this it is capable of storing the 1 bit information for storing and responding only when the specific edge of the clock pulses occurs. So this we call it as the pulse trigger flip flop. And here the realization of this flip flop is given here. And dual positive edge triggered flip-flop is nothing but the output state of this edge triggered flip-flops updates only when the specific edge of the clock pulse occurs. That is, the clock pulse goes from either low to high or high to low state. Mainly this flip-flops does not respond to any continuous clock pulse, so the edge triggered flip-flops is used in the different digital circuits when there is a changes from 0 to 1 or 1 to 0. And there are two types of edge triggered flip flop. One is positive edge triggered flip flop and negative edge triggered flip flop. So in the case of positive edge triggered flip flop, this type of edge triggered flip flop occurs whose output changes its states on the rising edge, so that we call it as positive edge flip flops. And the positive edge triggered flip flop is also called as the rising edge triggered flip flop. Here this positive edge flip-flops, the inputs are accepted and stored only when the clock pulse goes from low to high, and there is a rising edge on the each clock pulse. So this information stored value is then available to all the outputs. In the case of negative edge triggered flip-flop, this type of edge triggered flip-flops whose output will be changes only from the falling edge, that is from high to low, so that we call it as negative edge triggered flip flop. This negative edge triggered flip flop is also called as falling edge triggered flip flop. So in this case in the flip flop will be capturing and storing the information when the clock changes from high to low and low to high. And then the case of clocked flip flop, the inputs will be applied through the input terminals and the clock pulse is connected to the clock input. This responds to both the inputs from high to low as well as low to high. So you can see this occurs in the hold state as well as in the twiddle state. And main thing, the timing diagram is mainly determined responding to the applied inputs when this clock pulse goes from either low to high or high to low. When this transition occurs, the flip-flop will capture and stores the input values and available on the outputs. So precision timing module, here you can find out the threshold value. So if you have a control value, reset value and a comparator, the charging and discharging value based on the triggering outputs, this behavior can be improved while compared with the level triggered flip-flops. So this responds only on the transition of the clock pulse. And astable operation is nothing but, that is, it can be used in several devices. It can operate in both monostable and astable mode. It also requires an external resistor. It is also capable to set the width of the output pulse in the monostable state. So this provides good frequency stability at 50% duty cycle, and which makes the work with other TTL devices and microcontrollers. This IC is mostly used in the frequency discriminators, timing circuits, time delay applications, frequency multiplication and division. And this monostable circuits are mainly used for the for connecting the external capacitors to the pin between the resistors. So you can find out here the resistor, capacitor, RCC, stable, threshold, reset, external reset, trigger, VSS, output. So these are the operations used for connecting the external operators to setting the signal value from low to high or high to low. Then for resetting the value, and this q bar values acts as a non-inverting output, inverting output, and this output gives the oscillated output in the astable mode. Quiz questions on sequential circuits, difference between synchronous and asynchronous. Thank you.